Hello students, I hope you all are fine. So as you can see, we will today derive the equation of collision of a gas molecules with walls and find out the pressure equation. We have already discussed this derivation in another format, and today we will do this derivation using probability concept. Okay. So just follow the figure as I'm discussing this. So let A, B, C, D be one of the walls of the containing vessel, and DA, wait, I just show you, okay? So this DA be the elementary area of the wall, and consider an elementary volume dV at r, theta, and phi, which contains say as dnc dv, okay, number of molecules. So here d and c represents the number density of molecules with velocity about c. This number moves with velocity between c and c plus dc, and direction between theta to theta plus d theta and phi to phi plus d phi. Okay. Hence, the number of molecules that would move towards the area dA will be determined by the solid angle subtended by dA at the center of dV. Okay, so we have to find out this. So I just rub out this part. So what did I say just now? That we are going to find out the number of molecules that would move from move towards the area dA will be determined by the solid angle subtended by dA at the center of dV. That is, the number is given by dn. We can write theta phi and c, okay, equal to dnc dV, that is the number of molecules that is contained in the volume dV, by 4 pi into dA cos theta. Just revise the part of the solid angle from our previous class notes and you will be able to follow this, okay? So from there we can write dn theta phi c equal to dNCdA. Just substitute the value of dV over here, okay? So dV, I'm substituting the value over here. So it should be r square sine theta d theta d phi and dr. Please pardon my handwriting. Okay, into the cos theta, this entire thing by 4 pi r square. I have just substituted the value of dV in the above expression. The following line would be dn theta phi c equal to dNc dA sine theta cos theta d theta d phi and dr by 4 pi. Okay, this expression gives the number of molecules moving towards dA with velocity between c and c plus dc and direction between theta and theta plus d theta and phi plus d phi and from a distance r. Okay, so you all find this expression in your respective copies, you write down. Okay, then what we will do is that we have to find out how many will strike the area dA in time dt coming from all possible directions and all possible distances. Therefore, I'm just changing the color of this so that you can follow better. Therefore, the total number of collisions made with dA in time dt will be, please all of you write down, will be equal to, I'm finding out the total number of collisions, so I'll use integration. Therefore, put all the limits. C would be from 0 to infinite because the velocities ranges from 0 to infinite. The value of theta would be from 0 to pi by 2. Then the value of phi would be from 0 to 2 pi, and r would be from 0 to CDT. What is this? Actually, it's the distance that is being covered in time dt with a velocity c. And then write down the expression as it is. You have got that is dNc by 4 pi dA cos theta sine theta d theta d phi and dr. Okay, try to write in the same line as I was showing, so I have just gotten to the next line. Make this expression number 2. Okay, so bring out dA by 4 pi outside the integrations, and theta is equal to 0 to pi by 2. We have sine theta cos theta d theta, then phi is equal to 0 to 2 pi. So d phi over here, then you have dr and you have dnc. So it would be c0 to infinity, and this would be r equal to 0 to c dt. I hope it's all clear to you. Okay, then we can write 1 by 4 pi. Just simply derive this part. Okay, dA dt, and you have c dnc. Okay, you have theta is equal to 0 to pi by 2 sine theta d theta, sorry, sine theta cos theta would be there. So sine theta cos theta d theta, and you have d phi. Okay, do you have any queries up till this portion? Okay, the next part will be put all the values of the respective integrations over here. So dA by 4 pi dt, you have 0 to infinite C, D, and C, and the value of this respective integration is this, and from phi 0 to 2 pi you get the value 2 pi. For this part, this calculation part, I have shown you in the previous video, simply that calculation only. So just go back to that part and check how the calculation is being done to get the value half and to get the value 2 pi. Okay. So finally, the equation that I arrive into is 1 by 4 dA dt 0 to infinity C, D, and C. Okay. Make this equation number 3. Now, I need to substitute this part with some value. So, in order to do that, the substitution part that C, D, and C should be substituted, we should have a small calculation over here. I'm just providing you with the concept that since average velocity is given by C bar, that is what? N1 C1 plus 2 C2 plus dot 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 with divided by the total number of molecules, right? Okay, so this we can write as C bar equal to, I can just write this entire part as summation of Ni Ci, where I will be 0, 1, 2, 3 till n, and also this part as Ni. Okay, so I can also write in integration form as 0 to infinite C, D, and C by n. Just the thing that this summation part can be rewritten in the format of integration part, where I can just replace this thing. Okay, so I can therefore write the C bar is equal to integration of 0 to infinity C, D, and C by n is equal to NC bar is equal to 0 to infinite. Just cross multiply this part. Okay, NC bar is equal to C, D, and C. Now you can replace this entire portion in the previous expression in over here with NC bar. Okay, so substitute the value of this very equation in equation number 3. So you just write substitute and value above value in equation number 3. Tell me how much you're getting, what you're getting. Tell me what you're getting. Hence, I can write the number of molecules striking the area dA of that wall, okay, of that vessel containing vessel wall in time dt sorry, in time dt is equal to 1 by 4 dA dt integration of 0 to infinite C D and C. Okay, replace this part with NC bar. Okay, replace this part. We have derived the values with NC bar. So I'm just rubbing out that part. And I will replace that part with NC bar. So you got this expression? Make it as expression number 4. Up till now, any queries? Please leave your questions in the chat box so that it's easier for me to answer your questions. And whenever you have any query, just unmute yourself or you raise your hand. Now look at this figure. We will now calculate the change of momentum suffered by the molecules that is striking that unit area in unit time. So a molecule striking that area, this area dA, makes an angle theta as shown in the figure. Okay, on reflection, what happens? It will make the same angle. So the normal component of incident momentum will be mc cos theta, and that of reflected momentum will be mc cos theta with a negative sign. Okay, so the normal component of incident momentum is this, and then that of reflected momentum is minus mc cos theta. Okay, are you following? Therefore, the change of momentum suffered by each electron will twice mc cos theta. Okay, are you following? So the total change of momentum suffered by all the molecules striking that area dA in time dt is, actually we'll get it from equation number 2. Okay, so what we will do is we'll find out. So the total change of momentum suffered by all the molecules striking the area dA in time dt is, from equation 2, what we can write is integration from 0 c equal to 0 to infinite, then you have theta equal to 0 to pi by 2, phi is equal to 0 to 2 pi. We have dnc by 4 pi sine theta d theta d phi dot, what we will write over here, c dt dA cos theta, and we have now this part of momentum, this part will include that as well. We have 2mc cos theta. Have you got this from equation number 2? Okay, I'm proceeding to the next page. So from there we can write m dt dA. Stop me wherever you find you are unable to understand. Okay, 0 to infinite. We have c square d and c, and theta is equal to 0 to pi by 2. We'll have cos square theta, sine theta, d theta, and phi is equal to 0 to 2 pi. It's d phi. Okay. Yes, who is this? Yes, we have previously found out all the values of this integration, and the one that is sine theta, cos theta, d theta. All those were done in our previous classes. So just go back to those classes and you will be able to follow how to find out the integration values of this. We'll just substitute the values over here. Okay. Yes. Okay. Now, like as previous section we did that we have found out C, D and C value. Over here we'll find out C square, D and C square value. So if per unit volume N1 number of molecules have C1 velocity, then N2 number of molecules will have velocity C2 and so on. Okay, I'm repeating. I said that if per unit volume we have N1 number of molecules that has velocity C1 and N2 number of molecules that have velocity C2, then we'll have N3 number of molecules with velocity C3 and so on. Then we can calculate C bar square. How? N1 C1 square plus N2 C2 square plus dot 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 by N1 plus N2 plus, okay. What we can write over here, C bar square is equal to 0 to infinite C square DNC, okay, by N, or just cross multiply NC bar square is equal to 0 to infinite C square DNC. Okay. Are you following? Now what will you do? You will substitute the value of 0 to infinite C square DNC square, sorry, DNC over here in equation number 5. So substitute this value in equation number 5 and tell me the result what you are getting. So putting the value in equation 5, we have the total change in momentum, the total change in momentum suffered by the molecules striking area dA, of course in time, dt, okay, will be m dA dt by 2 pi into n c bar square into the value of that respective integration comes to be 1/3, and from the value of phi integration is 2 pi. So we get 1/3 m n c bar square dA dt. Okay, make this equation number 6. Any queries up till now? We are on the verge of completion of this very pressure equation. So I'm just moving to the next page. Now, if dF be the average force that is being imparted by the striking molecules, then we can write dF into dt is equal to 1/3 mnc bar square dA dt. Okay. So dF be the average force imparted by the striking molecules. We get this relation, or I can write dF by dA, okay, is equal to 1/3 mnc bar square. Okay. Now what is this actually? This dF by dA, that means force per unit area, change of force per unit area, what you get? We have pressure. So I just rub this part and I can write this is equal to P, which is equal to this. Sorry, my hand just pressed against. Okay, so this is my ultimate equation that I want to find out. Now if we introduce the root mean square velocity c, then we can write this expression as 1/3 mn c square, where c is the root mean square velocity. Okay, so I hope this derivation is clear to you. If you have any query regarding this pressure relation, derivation of this pressure relation, then just ask me. I'm waiting for some time. Okay, after this we will do some simple deductions from this pressure expression itself. Okay, some small 1-2 marks question that comes. Okay, thank you.